So we saw earlier a case like this where we have a data set which is basically pairs of xi, yi and I going from 1 to n such that xi belongs to Rd and yi belongs to two classes 0 and 1. This is what we saw, right? So here when I say yi belongs to 0 or 1 in the Amazon Fine Food Review, right? This is in the Amazon Food Reviews dataset that we just saw and which we're using as a running case study. Here 0 meant that it's a negative class, that it's a negative review. 1 meant it's a positive review. One thing you'll notice is there are two classes here. In this problem, there are two classes, right? Classes 0 and 1. 0 representing that the review is negative and 1 representing that the review is positive. So this problem where your yi is only two classes is called a two-class classification problem. It is called a two-class classification problem. It's also called a binary classification. It's called binary because it's two classes, right? Because you have 0 and 1. Similarly, a slight variant of this is, let's take our MNIST dataset. Our MNIST dataset, some people even call it MNIST dataset. I'm just trying to convert into a closed word. I'm just calling it MNIST, but I think some people prefer to call it as MNIST dataset. Okay, so here what do we have? We have each of the images, right? Here in MNIST dataset, each xi represents an image, and yi could be either class 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It could be any of these images. So here you have 10 classes, right? So this is called a 10-class classification problem. It is called a 10-class classification problem. Oftentimes it's also called as a multi-class classification problem. Multi-class because it's more than two classes. It's no more a binary classification task. It's a multi-class classification. Now by just changing, see, we're going from a two-class classification to a multi-class classification by just changing the number of classes that it belongs. But one thing you should notice is there are two classes here and there are 10 classes here. What if your yi is no more a small set? What if your yi is a set of all the real numbers? Right? Now one thing you'll notice is, what does this mean? This means your yi is no more belonging, is no more part of a small finite set of classes. Right? Let me give you an example. So as to make this more concrete for you. Imagine if my xi, suppose I have, let's say I equals to 1 to, let's say 10,000 students, right? And for each student, let's say you might have their weight, right? I have their age, I have their gender, whether it's female or male, and I also have their race or ethnicity, whether they're Indian, American, European, Caucasian, or Chinese, or Korean. You have the race, right? So imagine, given this information about a student or about a person, basically. Imagine this. Imagine I have such 10,000 data points. Imagine if I want to predict the height of this person. Now, one thing you'll remember. So this is also a very nice function, right? You can also write this as this. Given all these values, given weight, age, gender, and race, I want to now compute a function that returns me the height, right? This is also perfectly valid. Such problems. Now, your height is a real number, right? Your height is a real number. It's no more a class. Your height could be 182.6 centimeters or 152.7 centimeters. It's a real number if you look at it in centimeters, right? It's no more like the classes here. Here we see whether positive class or negative class or class 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here it's a real number because you're trying to predict a height. Such problems where your yi is a real number are called regression problems. They're called regression problems. So the only difference between classification and regression in a nutshell is in classification, see, we'll keep using this notation, right? In classification, in binary classification, your yi belongs to one of the two classes. In a multi-class classification, your yi belongs to multiple classes, but still a finite set, right? Here it is 10 class. We could have cases where it's 20 class. Typically more than 10 classes is rare, right? Or You can have a case like your height prediction. So this system is predicting the height, right? So this function is trying to say, given weight, age, gender, and race or ethnicity, I'm trying to predict what is the height. Here, your height is a real number. It could be any number like this. Such problems are called regression problems. So the only difference between classification and regression is what the values of yi are. So if yi is like this, it's a classification. If yi belongs to a real number, then it's a regression problem. So this is your standard classification problems. These are your standard regression problems. So what we'll do is, throughout this chapter and in the chapters going forward, classification, regression, everything remains the same except the small change. So if there is a technique that we learn which can do both classification and regression, we'll call it out.